So in this video, we will learn about equations of motion applied in rectangular coordinate system, topic 13.4. This is theory portion of the video, and in the next video, I will solve some problems. Equations of motion, rectangular coordinates. Apply Newton's second law to determine forces and acceleration of particles in rectilinear motion. That is the objective of this video. In dynamics, the friction force acting on a moving object is always kinetic friction. So there are two types of friction, static friction and kinetic friction. Static friction is when for static friction, we use mu s, which is static friction, s stands for static friction, and mu k is used for dynamic friction. Static friction is when the object is not in motion, or the maximum friction that's possible between the object and the surface that it's resting on to correct that motion. And then mu k is dynamic friction or kinetic friction when the object is in motion. If a particle is connected to spring, the elastic force expressed by F equal to Ks. In that equation, S is called the difference between the deformed length and undeformed length of the spring. So if the spring has, let's say, originally length 1 meter, for example, and when the force is being applied, spring changes its length to 1.5 meter, then this is called deformed length, this is called undeformed length. So S in that case is 1.5 minus 1, which is 0.5. Okay, so this is the correct answer. Now a few applications of rectangular coordinate system. So in this example, a man is trying to move 100 kilogram crate. How large a force F must he exert to start moving the crate? So what factors affect this influence this force? So it depends on the weight of the block. It depends on the now we also, from the weight, we can calculate the normal force, and from that we can also calculate the friction force. And then this is the applied force. Now applied force is at an angle, so F cosine 30 is the only useful component of the force, while F sine 30 acts vertically downward and it does not cause any motion of the block. So by drawing a free body diagram and corresponding kinetic diagram, so this is FBD where I have indicated all the forces, and in corresponding kinetic diagram is MAX. We can apply sigma F equal to MAX and calculate the required force for the given motion. Another application, objects that move in air have drag force acting on them. This drag force is function of velocity. Okay, so this is the drag force, which is function of velocity. If the dragster is traveling with a known velocity and the magnitude of the opposing drag force and at any instant is given as a function of velocity, can we determine the time and distance required for dragster to come to stop if the engine is shut off? Yes, we can calculate that if we know the velocity of the dragster, if we know the traction force applied by the engine onto the dragster, and then this air drag resistance, which is acting in the opposite direction, we can apply again sigma F equal to MAX and calculate the required quantity. Sigma F equal to MA is a vector equation. For this part, we apply that to Cartesian coordinate system or rectangular coordinate system. We also call this XYZ coordinate system. So this one vector equation can be split into its components, where sigma fxi, where sigma fx is sum of forces in x direction only, sum of forces in y direction multiplied by unit vector, z force multiplied by unit vector, and then corresponding components of acceleration. By equating these two components, we can by separating I and j components of this ijk components of this equation, we can get three scalar equations, that is sum of forces in x direction equal to mass time x acceleration, sum of forces in y direction equal to mass time y acceleration, sum of forces in z direction equal to mass time z acceleration. And these equations are called equations of motion, or EOM, for rectangular coordinate system. Free body diagram is always critical, so make sure you draw a free body diagram, indicate all the external forces such as weight, spring, normal, friction, depending on what information is given in the problem. And the next step is you draw kinetic diagram and apply equations of motion in rectangular coordinate system as shown here. So you can apply one vector equation, or you can apply three scalar equations, 1, 2, and 3.